Hello, my mathematicians. This is Miss Foster with Multiplication Level 2. What you already know. Can you believe it? You probably know half of multiplication. Over here we have a multiplication table, and this shows you all of the multiplication knowledge that you have to become cozy friends with and get strong strategies for before third grade. So that looks like a lot to do, doesn't it? Don't worry, you already know at least half of it or more. So let's get started. We're going to be looking at lots of different factors here today. And let's start with multiplying any number times 0. So here I have a bundle of 2 pencils. Let's pretend that I need 2 pencils and the store is selling them for two pencils for whatever kind of money. If I go to the store to get my 2 pencils, but they have no pencils, I will get 0 pencils. Any 2 times 0 equals 0. Well, that makes me wonder, what if the pencils came in packs of 3? Well, if each pack of pencil came in with 3 and they didn't have any, so I got 0 pencils, how many pencils would I have? 0. What if they came in groups of 8? 8? There are 8 pencils in each package, and I just want one of those packages, but when I get to the store, no packages of pencils. How many pencils would I have? 0. Do you notice a pattern here? When we are looking for our strongest strategies in math, we are looking for strategies based on patterns. And I am noticing that 3 times 0 is 0, and 8 times 0 is 0, and 2 times 0 is 0. In fact, boys and girls, any number you want to play with times 0 is 0. And we can write that using a variable. I'm going to use a letter to stand for any number in the world, and I'm going to use the letter N for number. Any number times 0 equals 0. Even the number 28,572,3,564 times 0 is 0. You've got it. We're done with that. Let's try any number times 1. What about the factor of 1? Well, if there are 2 pencils in each pack, and I get just 1 pack of pencils, I will have 2 pencils. 2 times 1 is 2. What about if there were 3 pencils? Well, if I go to the store and I want a pack of pencils, and there are 3 pencils in each pack, and I buy just 1, I will have 3 times 1 is 3. If I go to the store to buy a pack of pencils, and there are 8 pencils in each pack, and I only get 1 pack, 8 times 1 equals 8. Wait a minute! It looks like another pattern! In fact, if I wanted to use my variable again, using n for any number in the world, any number times 1 will equal that same number. Like if I went to the store to buy 1 package of pencils and it had 7,095 pencils in there, and I got just 1 of those packages, I would have 7,095 pencils. And that means, my friends, you'd already know how to multiply anything times 1. You just have to think about what makes sense. Let's go on to 2. Sam has 4 bundles of pencils. There are 2 pencils in each bundle. How many does he have? Let's draw a quick area model for this, just quick. My factors are going to be 2 and 4. Okay, so, well, anytime we're multiplying by 2, we have an addition fact that can really help us because you have already learned how to do your addition doubles. And an addition double is when you just add the same addend twice. So if I know that 4 plus 4 equals 8, then I know that 2 times 4 also equals 8. So I can use my addition doubles to help me do any number times 2. Also, though, you might be thinking, wait, Miss Foster, I know how to count by 2s. Watch. 2, 4, 6, 8. Isn't that incredible? You do know how to count by 2s. The thing is, though, I don't want you to fall into the trap of always skip counting and counting by 2s to do these. Skip counting is a great beginner strategy. But thinking about how you know this addition relationship and you can use that with multiplication, that actually helps your brain to think on a much higher level. Don't tell all the adults, but it's kind of how algebra works, which means you're doing algebra in this lesson. Oh my goodness, you guys, if they know that, they're going to think you're a genius. I happen to think you're a genius, but just be gentle with them. They're adults. You know how they get crazy. Okay. So when you're practicing times two, you always can count by twos. But the challenge here is to use the addition doubles to help you get there, to form that strong connection. So now you know how to multiply any single digit number by two. Wait a minute. What about 5? Well, I bet you know how to skip count by fives. Do you know 5 times 2? 5, 10. Oh my goodness. And down here they've given you this lovely array model of 5 times 2. In fact, because you can skip count by fives, you can already multiply anything times 5. Like 5 times 5 would be 5, 10, 15, 20, 25. And if I wanted to do 7 times 5, I could start at that 25 and go 27, or I'm sorry, 25, 30, 35. So you can do all that skip counting for 5 too. But 5 is really a benchmark number. It's half of 10, and we know how to skip by it. We have 5 fingers on our hands. Yes. So what if I was trying to do a really hard problem by 2? I might choose to use counting by fives to help me get there. Check this out. 7 times 2, if I forgot that I could use my addition doubles, but I remembered that 5 times 2 is 10, I could say, I can divide this into 2 steps. I know that 5 times 2 equals 10. And I know that 2 times 2 equals 4. And so what I've done here is I've used a number bond. I know that 7 has a number bond with 5 and 2. 5 plus 2 is 7. 10 plus 4 is 14. So 7 times 2 equals 14. And that's me using a related multiplication fact to help me get at a more challenging multiplication fact. And that is a super strong, powerful strategy. Now, the last bit of multiplication that I think you already know is any number times 10, because you know how to skip count by 10. So 3 times 10, we could easily skip count and go 10, 20, 30. But here's another cool thing that you might want to try using. You could use one of my favorite things ever, place value. You know that in our number system, to the left of the decimal point, we have the single ones place. And I'm going to abbreviate that SO for single ones. And then we have the tens place, which I'm going to abbreviate with that very scoopy T. Now, if I'm doing 3 times 1, can you imagine those little tiny single ones that we have at school? That would be one group of 3, right? And that would put a 3 right here in the single ones place. But if I am doing 3 times 10, I'm not multiplying those little tiny single ones anymore. Oh, no, my friends. I am multiplying these 10 rods. In fact, I get 3 of them. And you already know that if there's a 3 in the tens place, you have to have a 0 in the single ones place if you don't have anything else there, because what the 0, our very great hero here, is doing is it's shoving the 3 over into the tens place. So I could use place value to say, well, 3 times 10 is 3 tens and 0 single ones. Whoa! You already know how to multiply by tens! Oh my goodness! Now, this is just a little reminder down here at the bottom, we're going to skip one, that we can use multiplying by 10, since we already know it so well, to multiply more difficult numbers. Like, what if I'd asked you to do 8 times 5? Well, you could skip count up to 5 8 times, by 5 8 times, but that's going to take me a super long time. What if I could use what I know about multiplying by 10, using my place value? I know that 1 times 5 is 5. And so I also know, if I use place value, that 10 times 5 would be 50. So I know that. I have another relationship though. I know that the difference between 10 and 8 is 2. because 8 plus 2 equals 10. See, you already learned that. So, let me, excuse me, let me draw you a quick area model for this. Okay, this is 50. This is my area model, and it is a box that represents 50. And the factors I have here are 10 and 5. That's what I'm starting out with. Right, 5, there we go. But now I'm going to use this special relationship right here between 10 and 8. And I'm going to say, well, I know that if I take 10, I can have 2 in this group and 8 in this group. Okay, well, I know that 5 times 2, see, instead of doing 5 times 10, now I'm going to do 5 times 8 and 5 times 2. But I can start with what's easy. I know that 5 times 2 is 10, don't I? And I can easily do 50 minus 10. It's 40. And that's another way to find that 8 times 5 is the same as 50 times 10. It's 40. Whoa! You have just learned that you already know how to multiply more than half of this multiplication table. Let me just prove this to you. Just one more minute. All of the times 1, any number times itself, is that same number. And on our multiplication table, that's highlighted now in yellow. Well, I know my addition doubles, and I can skip count by 2, so I can do any digit times 2. And that means I've got all of my times 2 there. This is starting to look a little smaller, but I'm going to make it even smaller again, because you know place value. And so any single digit number, even 10 times 10, you already know it. You just use your hero 0 to bump that digit into the tens place. And you already know that much. This is getting to look smaller, but I'm going to chop it up even more because you know how to skip count by 5s. And because you can use 5 and 10 and your number bonds for that number, you already know the blue stuff also. Wait a minute. You guys, you already know half of multiplication. Wow. So I want you to try it for yourself. In the packet I sent you, you're going to complete practice pages 4 and 5. Now I'm going to give you a special challenge. You can skip count, but try using patterns and connections and relationships, particularly number bonds, relationships between 5 and 10 and other numbers, using those big benchmark numbers of 5 and 10. See if you can use those to do some really tricky ones. Like if you were trying to do 5 times 7, I mean, I'll be honest with you, that was a hard one for me to learn. What relationships can I use? The strongest mathematicians use strategies based on pattern, connection, and relationships. Now, if you need help, please get with your adults. I know they can help you with this. And you are welcome to rewatch this video just as many times as you need to. Oh my goodness, guys, thanks for playing multiplication with me. Isn't it exciting to see how much you already know? Wow! Thanks for playing math with me. I had fun playing math with you. Bye-bye for now.